Welcome back. Yep, it's Calc Teacher again. And now, like I told you where we left off, we're going to be using trigonometry now to eliminate a parameter. So here is two parametric equations. Now our parameter here now is theta, as you can see. So we want to sketch a curve. But in order to sketch this curve, we're going to eliminate the parameter and turn it into a rectangular equation. So the first thing we're going to do is we're going to solve for cosine and sine. So the first thing we'll do is cosine of theta is equal to x over 3. And sine of theta is going to equal y over 4. You got it. And now we're going to make use of an identity to form an equation involving only x and y. So what identity do you think we're going to use with sine and cosine? Well, if you guessed the Pythagorean identity, you would be correctamundo. And we're getting this. So now we're going to, instead of sine, we're going to put this y over 4 squared plus x over 3 squared equal to 1. Now you're like, why would I ever think of that? Well, these are techniques that you would learn to use over time. But you're turning something with a parameter of theta and x into something with just x's and y's. We're eliminating the parameter of theta. So simplifying this, we get y squared over 16 plus x squared over 9 equals 1. Now, does anyone know what this is an equation of? What this looks like? Nobody? If you remember your conics from maybe one class, I don't know, GT geometry, maybe you learned conics, but somewhere you may have learned some conics. This actually looks like an ellipse. Oh, let's see how beautiful that ellipse is. Oh, beautiful. Where these values here are negative 3 and 3 from this, and then you would guess that this and this would represent from here, would be represented from here, would be 4 and negative 4. And again, it's if you use the parametric equations, you would see that it went in this kind of direction, going around like this, in that kind of direction. Okay, so that's how you can determine that. So if you wanted to move on and continue, you should be able to notice that if you wanted to use the same technique, that any parametric equation in this form it should be sine theta. In this form, when theta is between 0 and 2 pi, is an ellipse traced counterclockwise, given by this formula. Same idea, counterclockwise. So remember the direction that we had before, over b squared equals 1. The other way, x equals h plus a sine theta, and y equals k plus b cosine theta. For the same values of theta, this would be giving us an ellipse traced clockwise. Sorry, I didn't mean to draw that. And we're left with this formula. So you can kind of play with that if you have your graphing calculator in parametric mode, kind of fooling around some things with that, with equations like this. And you'll see, and when you do that in mode, when you look at, or the window, I'm sorry, you'll have a t that you have to, the parameter t that you'll have to kind of deal with. So that's kind of cool. So what else do we have to do? Finding parametric equations. Okay, so you want to find a parametric equation. Let's find a parametric equation given this. We have y equals 1 minus x squared, and we have two parameters. There it is. We're going to find a set of parametric equations to represent this. So the first one we're going to do is when t is equal to x. When t is equal to x. So when we let t equal to x, we have a very easy set of parametric equations. Here's one of them, x equals t. And then by just allowing x to be t, we get that. So there you have it. That's one set again, we need to have some sort of parameter on here in order for this to be true. You can't just pull it out of nowhere. So part B says that the slope m is equal to dy dx. Okay, the derivative, no problem, at x comma y. So we need to express s and y, x and y in terms of the parameter m. So we can proceed as follows. So let's see, what is the derivative of this? Our derivative is going to be dy dx, but in this case it's going to be just negative 2x. So that means this implies that x is equal to negative m over 2. This produces a parametric equation for x. To obtain one for y, we need to substitute this into the original equation. So y equals 1 minus negative m over 2 squared, which is equal to 1 minus m squared over 4. So my two parametric equations are going to be this guy, and then this one as well, set equal to y. Again, parametric equations are just equations that have a third parameter. We have x, y, and in this case our third parameter is m. So I'm just showing you a couple of examples before we move on to the calculus of parametric equations. So again, look at this video as many times as you want. You'll see that it kind of goes along with some of the stuff that's in the textbook this time, just so that you have another reference point. But you'll see as we go on, I'll try to bring some things in from other sources other than just the textbook. So I hope you enjoyed this. Johnstone out.